What's happening, folks? Geologist Philip Prince looking out over western North Carolina into Tennessee today. This view looks really, really interesting if you put some colored digital topography over it. See all the really rugged mountains there. Actually, you're looking out over Asheville in the foreground, and Knoxville is up there, sort of in the top left in the distance. It's worth marking those on there because if you go from Asheville, which I'm drawing right now, to Knoxville, out here in the distance or beyond, you're going to have to travel out of those really rough mountains. And if you're just looking at this map, you can see sort of a grain and pattern to the mountains there. It seems like you might just go down this river valley and out into this flatter terrain and over to Knoxville like that. Well, that's not what you do. In fact, from Asheville, head in this direction. You go up along Hominy Creek past Canton, North Carolina, and then you follow another river through a really tight gorge out like that to get to Knoxville. And that, of course, is Interstate 40. If you're from this region, if you're a person that felt the earthquake last week, I-40 is something that you've heard about before. It's a pretty notorious place, for lack of a better word, because it's always having some kind of geologic problem. There's a rock slide, something happened to the road. The road's closed, a lane is closed, something like that for years and years, actually almost for the entire lifetime of the road. There's been something like that going on there. Of course, that's definitely been the case since Hurricane Helene, but these problems date back to long before that. So this video is going to talk about what actually is going on over there in I-40 and what might be different if the road were over here to the east along the French Broad River. The section of I-40 that you always hear about, though, is certainly one that is pretty recognizable in terms of the topography here. You just have to look for this crazy rugged gorge of the Pigeon River cutting through the Great Smoky Mountains to the southwest and sort of a lesser zone of Blue Ridge topography to the northeast that's not quite as high, but is obviously plenty rough, and you can't put an interstate up along that, right? So the river gorge here does provide a way to get out of the mountains, but you can see just from how the colors change in this map, the colors reflect elevation. If there's a lot of quick color change, that means things are really steep, and you go from very low elevation to very high elevation really fast along the Pigeon Gorge here. So it's a really sort of like a mountain canyon almost. And the interstate, as you'll see momentarily, ends up just sort of kind of snaking along the edges of it. There's a tunnel right there, and you end up with an arrangement kind of like that on your way over into Tennessee. So just from looking at the landscape, you get a sense that this might be a pretty challenging place to put a road and to keep a road open. If we fade those maps away, we'll actually turn those off because we're going to take a look at some lidar imagery that's really going to give you a sense of what's going on here geologically. Looking at this area is interesting because the imagery is changing as Google Earth uploads new material after Hurricane Helene. And in fact, you can see places in here that were heavily damaged by Helene that are still being repaired. Take a look at those two here in just a moment. But we'll focus in on this area first. I'm actually going to turn the clock back here a little bit to get away from that snow-covered appearance. And we'll turn on some lidar there. The reason that lidar is so useful, you hear about it in my videos all the time, is that it lets you see what the land actually looks like beneath the trees. Fortunate enough to have plenty of trees here in the southeastern US, but if you're thinking about geology, sometimes they can kind of get in the way of seeing some pretty important details, and that's absolutely the case in this part of the Appalachians. But as we get zoomed in here, we're going to turn this view around. You can see the road cut of the interstate there quite clearly. So that's I-40. We'll actually fade this away just so you can get a sense of what you're looking at. You can see the traffic's pretty bad there whenever they took this when they took this Google Earth imagery. So that's the background landscape, and immediately one gets the impression that there's a lot of rough, rocky topography around the interstate. And if you start to look closer, you're able to pick up pretty quickly on what is the main reason that I-40 is always being talked about in this area, and that is what you would call essentially the grain of the rock in the landscape. Look closely in the background here, and we'll remove these lines. You can see that there's absolutely a distinct tilt to the layers of the rock. You see it around that tunnel there very, very strongly. And those layers actually tilt down towards the road. If you have a road like this, you're going to have to cut a little bit of the slope away to have room for the road. And if you cut the base of a slope with the layers tilting like that, it's not really a stretch to visualize those layers being pretty interested in sliding downhill. And that really, in a nutshell, is the big challenge with Interstate 40. As far as any kind of human construction goes, this type of issue is really common. And in fact, if you were to look at videos on this channel, more than one of them talks about engineering situations where you end up cutting into a slope where the layers tilt down towards it. This is one of the better examples, I think, on the East Coast and probably nationally where that has turned out to be a problem. And it's an interesting one to sketch out here because it actually allows you to visualize what's going on, what you have to do to put a road here to begin with, and also kind of some of the considerations that would lead to a road being put on the side of the gorge that it is in the first place. So let's do that right now. Kind of an interesting diagram, and again, one that you might see some similarities reflected elsewhere on this channel. So we'll try to get this rolling efficiently here. In some respects, this is a reasonably simple diagram to do, but putting the geology that I want in the subsurface is going to take a little bit of attention. That ain't going to work. I'm going to start that over. Bad luck. I don't know. Here we go. Something like that. Something like that. That's looking pretty good. Got to be able to bring my block down there in the back without covering myself up. So we're going to have the river sitting down here at the base of the slope. All right. Something like that. Here's the river, at the bank of the river right there, something like that. We're not looking at the entire mountainside here, right? This is just going to be sort of a representative part of the slope from the standpoint of trying to build on it. And this really right here is sort of what you came for. I'm going to have these layers tilting down the slope. Start to space these out now that I don't have to show those in the road cut here momentarily. Just try to get enough of them up there at the top where I'll be able to show the kind of detail that I'm after. I think that should work right well. I'm gonna try to fit one more in there. Ugh, dangerous. Do the same thing in this direction. Sort of like a connect the dots here. And you'll notice that the layers that I'm now drawing are also tilted. So the overall idea is that the geology here would be tilting almost like out of the screen towards you ever so slightly. So there's a little bit of an angle in it. All right, so we'll put the riverbank on there. We got the riverbank on there. There's the ground surface. Let's color in some of these rock layers now. I'm just going to use a couple colors here for contrast. The rock that is exposed in the Pigeon Gorge is metamorphic rock, which means it's been buried quite deeply in the earth to the point that it's been, for lack of a better way to put it, cooked a bit. That has changed the mineral composition, but the rock does retain quite a strongly layered character. That's what actually allows you to see the grain in the landscape so well, like you saw moments ago there in Google Earth. And it's that layered character that you see illustrated here that causes all of the problems. So got our hill slope here, got this tilted rock, and the river is right there at the very base of the steep slope. So imagine we wanted to build a road on the side of the slope here. Well, one option would be that you just come in here and cut an enormous chunk out of the side of the mountain. right away you can see that you're going to have a huge sliding issue with that, right? Don't don't even mess with that. How can you take a little bit of the pressure off the cut there? Well, you can pile up an embankment first and foremost like that. Might need a retaining wall on it. In fact, you probably will because it's going to need to be really steep. But that's okay. That's a start. So we'll get our embankment there, color it with some different colors. Okay, so now we got our embankment. We actually don't need to make quite as much of a cut, but we're still going to have a pretty good one there just to push that rock back from the road there just a little bit, right? So we know something like that. So we can get that outline now. So now we have our new land surface set up here. So that's pretty good. Okay. Very nice. Okay, so now we got plenty of good space to work with here. So let's put a big wide highway with good shoulder and everything on it. Something like that. Fill that in with a different color. Looking good. Okay, and now for the hard part. What are you going to see exposed in that road cut? Well, let's just kind of match essentially the tilt angle that you see down below there. In this particular case, there's a little bit of an angle on that cut, and that's actually going to allow you to see a slightly wider exposure of those layers. I bet I didn't count those correctly, and we're not going to worry too much about that here because we sort of got the idea that we need. So the final touch here, this isn't just layered rock. It's also extremely fractured rock. And if you drive by and look out the window on I-40, you will see that the rock is cut up like a checkerboard, right? So it is thoroughly broken, but in a very geometric and orderly fashion. Got fractures that are running like that. Okay, those are the ones we just drew. And as if that weren't enough, there's more than one set of fractures. So we've also got a bunch of them that are like this. They're steep, they're almost vertical, and they would run something like 90 degrees to that other set. So now we have rock sloping out of the cut onto the road there. The tilt of the rock is bad. It's broken all to bits just as a result of the fracturing. Some of the rock has the mineral pyrite in it. When it starts to weather, it makes slightly acidic solution. That makes the rock even weaker. It almost kind of dissolves itself a little bit. And all of that bad stuff is kind of looming above the highway there. I don't know. We need to put a vehicle on the highway here. We're gonna put a big truck on the highway here just to have kind of a frame of reference there. Have a red cab on it there. All right, so we got a vehicle on the highway here. Nice. Okay, so what do you see in terms of sliding behavior here? Well, uh, as I've been saying, you don't have to reach too far to get a sense of what's going to be going on here because it's pretty easy to just take, sort of like a wedge-shaped block, just like that, and have that link up with all those different fractures and just come falling out of the road cut. And in fact, that is kind of the I-40 classic right there. So we'll open ourselves up a big scar here where that failure happened. Okay, so that's going to look quite a bit different, to say the least, than it used to. You're going to see a big deep scar there on the side of the highway, and you're going to end up with a big pile of rocks down here. Fortunately, the truck was out of the way of that one. We'll fill those in with some color there. Cool. So there would be a lot more rock than illustrated there to fall out, but you would get the idea there, right? So it's that kind of kind of wedge-shaped situation where everything is just tailor-made to slide out. The rock is chopped up into blocks and cubes and ready to do that. The rock has weak zones in it. It's kind of like a mix of really hard layers sitting on really weak layers, and you can just repeat this process as much as you want to, right? I don't know. It's kind of cool to draw that in there. So we'll drop one more out here right in front of the truck. And we're gonna hope this guy's able to stop because this is gonna be a big one. All right, we'll take all that out there right now this time. Don't worry, he's gonna be all right. I actually don't know what the history of rock falls on 40 has been in terms of them interacting with active traffic lanes. There's a lot of considerations made to try to keep falling rock from, from getting down into the roadway. Some of the slides there have been absolutely huge and they've totally covered the roadway in the past. So I'm not sure what's gone on with that. And the way I drew that, oh no, that spells trouble for our vehicle here, but we're gonna go for it anyway. A bunch of these, that's a problem right there. Good gracious. So we're going to send a bunch of those even down all the way into the river down there. All right, so that's uh that's kind of the long and the short there of what you're dealing with geologically, at least from the standpoint of the rock. Now, what happened with Hurricane Helene? You had a big flood. The embankment there is also a big part of keeping the road in place. So there's the steep embankment side. That's fill material that's been brought in and introduced there to widen that buildable road area. Um, what's going to happen if you put too much flow against that? That's another one that's not going to require too much imagination, and you can just scour out a huge part of the slope there at high water and end up collapsing quite a bit of that road down into the river there, right? So there's vulnerability here because you got bad geology on the slope. You got a river cutting into the bottom of the embankment there, and this tiny little road that's packed in between there. So it's kind of like I-40 problems illustrated, and an interesting question here, and one that you might have asked when you saw the lidar imagery. Why don't you build the road on the other side of the river there? Like if you built it on the other side of the river, you wouldn't have the layers tilting down into it. They tilt back into the slope. That might actually be a really nice arrangement to have. Well, uh, no, you can't really do that. And the reason for that is that the tilt of the layering actually controls how steep the mountain slopes are. So if you took kind of a cross section of the gorge, it would end up looking something like this, something like that. And if we put our geology up under this arrangement, kind of like that. So here's our tilted layers. So nothing too unfamiliar there. We'll put our river kind of flowing along down here, kind of like that. And we can even add a little bit of detail here going up the walls of the gorge. This is something that you see really strongly developed and something that we'll take a look at momentarily. We hop back to the lidar. Frequently you end up with an arrangement like this where the side of the river where the layering is tilted into the slope is basically just cliffs. Like it's way steep compared to the side where the layer is tilted down. So the profile of the gorge looks like a check mark or something like that, where you got a really steep side, and then you have a side that's moderate enough to build on. And sure enough, that moderate enough to build on side is where the interstate's actually been put there. So the geology is against you just about any way that you look at it here. And what I just illustrated there is exactly what you're seeing in the foreground here. There would be absolutely no way that you could make a road embankment, something like that. The cliffs above you, the size of the cut slope you'd have to make, you're already in an outside bend of the river, so the river's scouring at the toe of the slope. You at least have a more gentle slope on that side that you could possibly work with. So it's really a remarkable place. And in terms of working, I guess working with what you got here, the road has done that to the extent possible. And there's limits on that possibility. This is a really cool view of it here, where you're looking into that far bank. In this particular case, the layering is tilted quite steeply. There is folding in the rock layers here. This one looks really interesting. If we take a look at what's just there on the land surface, you don't see those rocks, but you can almost see that like skeleton of the mountain almost. Looks like ribs or something. So really, really an amazing place to look at in terms of the land. But man, you got your work cut out for you here, trying to trying to make things work. In this view, you can also really nicely see that crazy steep versus a little bit more tolerable geometry there. The further you go downstream here, honestly, like the worse it gets in many respects. And once you get down towards Hartford, Tennessee, into Cocke County, Tennessee, some of the worst slopes of all are in this area, and this lidar view shows them very nicely. We'll let everything load up there to be sure it's visible. But right here on the east or the northeast side of the road, you can very clearly see where we got these big slabs here, and just as drawn, they're tilting right down into the road, and material has already been lost from them. Some of that's been removed on purpose, but if you look right there, when I take that line away, you can actually see almost like a little crack on the slope. That's what we call a scarp in geology, and that's where even more material is kind of thinking about sliding right there. So that particular slope is a really tough one to work with, and there's just really nothing to do about it because that's the way those slabby layers are going to tilt down onto the road. The way the river's bending there, you're going to only be able to do what you can do. Take yourself even further west there. I think this is actually one of the most famous bends for sliding that there is. You can see one absolutely huge one that's right under the hand. So kind of where I'm drawing right there, like a big block there has shifted a little bit downslope. I presume that's related to construction. The top of it up there, the way it's kind of a ragged crack, that's sort of what that tends to look like when you've got a younger feature or one that's been sort of brought to life by modifying the land. And I'm pretty sure that right down in this bend right here, where you have those crazy slabs that look almost like pyramids, there's been huge rock slide events there in the past. And that one's sort of I guess you could call that kind of the inspiration for the sketch there, where you've got layers that are a little bit angled to the trend of the road, and you can end up dropping sort of those like wedge shaped blocks out of there down onto the highway. So when you ride through here and you look out the window, you may not have thought about it before, but you can see all of this very clearly. And when you really think about it, it's actually kind of a wonder that the that the road has functioned as well as it has over the years. Right down here near Hartford, there's an absolutely huge feature on the side of the road. So we'll flip back, sort of looking back east here, and you may have already recognized it there, but there's kind of this big outline here with all these weird jagged cracks and lumps and bumps in it. That's where sort of the whole mountainside has shifted a bit. And again, I don't know that that is related to construction. The movement is very slight, but even if it's not related to construction and you had to come and cut the slope at the toe of that, Ooh, that's that one's also that one's kind of tough to sleep well at night thinking about. Got a little animation on the screen that I'll pop up right now that will give you a sense of sort of what that movement might look like. Again, it's a very slight movement, but it just shows you the geologic instability that's always going to be present here, regardless of what's happening down in the river. Now, you can't omit the Helene issue here because, of course, that literally took out sort of a whole chunk of the interstate. That was related to that fill material. So where I drew the bank sort of being washed away by the river in the sketch, that was what went on with Helene. And if we get rid of our lidar here and come back to this crazy looking snow-covered imagery, right there, just below the middle of the screen is some of that Helene damage. So we'll zoom in here and take a look at that. You can pretty clearly see that the road is very much missing right there where that fill material got scoured away. The way the river's flowing there, it's pretty well kind of tailor-made to be very be very sort of aggressive into the bank there and just scour all that stuff out of there and cause the road to collapse. So it's not like anyone's being negligent in the maintenance here because you're gonna fight this thing uh, pretty much as long as it's there, just because the nature of the geology is such that you can't really do anything else. So final question here, and one that you hear talked about quite a bit. Well, what if they just put the interstate somewhere else? I started this video looking down the French Broad River. That's another way to, if you will, get out of the mountains. You're looking straight down it right now. Let's see if we can turn on some good colored topography there. So there's the French Broad Gorge going out into Tennessee. The mountains aren't quite as rough there. It's generally sort of a nicer looking topography, but it's still quite steep. There's very much just up above Hot Springs, North Carolina, where we're zooming in here. There's still very much a steep gorge there. And in fact, a major highway that uses this corridor today uh, sort of has to kind of come up and out of the gorge. I think I've drawn that fairly well correctly there. You end up crossing Big Laurel Creek there before you go back up and over another gap and then down into Hot Springs. So through this area here, there's still bad topography to deal with. Is it as bad as 40? I don't know. I actually don't have an informed opinion on that from the geotechnical side. Geologically, it's a shorter stretch. It's just as steep and rough. This is a bigger river. This river has no dam control on it whatsoever. So it's a large and sort of naturally flowing river. So there's no restriction on its flood behavior from a dam. Waterville Lake on the Pigeon isn't really made to control floods, but there is some influence from that. So you've got rough topography, a huge river, and another interesting detail here, and one that will come up in what I hope is the next video on this channel, is just what the bedrock geology is under this part of the river. So if we turn on these geologic maps, there's a bunch of really crazy, funny colors that pop up. This is how geologists see the landscape. It's sort of color coded, if you will, by what type of rock is at the surface. What you got here where the French Broad cuts through, and I think maybe we should actually draw the French Broad in underneath there. See how this looks. It's getting tough to pick colors here. So we can doing an okay job right there. It's kind of the general course of the river. If we go through and click on various features with our map here, it's going to tell us got a fault there, got a fault there, got a fault there, something called the Rome Formation there, which is a really soft, weak rock type. Got the Shady Dolomite here, which is another weatherable rock type. It actually gets caves and sinkholes in it. And just generally speaking, a really crunched and broken up mass of rock. These faults aren't active. They're not causing earthquakes like the one that we just had, but they are sort of the breaks, if you will, along which the mountains were assembled long ago. And anytime you're dealing with faults like this in the landscape, the rock around them tends to be really broken up and very weak as a result of that. So yes, the terrain is a little bit better along the French Broad, but is the geology that much better? I really don't know. Probably the best way to think about that is to ask the question, why would the river go there? Rivers are really good at finding the best path downhill, which means they are really good at finding the weakest rock around. So when you look at a river like this that's using that area to get, if you will, out of the mountains, it's usually pretty reasonable to infer that that river is going to be flowing through some of the weakest geology that it can find. So you might actually not be that much better off to use the French Broad. And the final thought on that is that I-26, which is just sort of off the screen to the right here, it doesn't go anywhere near any river. It literally goes over the mountains. It has huge road cuts, but it avoids bad geology with broken rocks. It avoids almost exclusively that really kind of steep gorge topography you get in these rivers. And in that sense, through the mountains, it's sort of a better place to put a highway. Now it crosses the Nolichucky and Irwin, which of course with Helene had a tremendous impact and closed the interstate there. But at least through the mountain stretch, that idea of just avoiding river gorges, in some ways it makes more work, but at the end of the day, it could end up being sort of a longer term, lower maintenance solution. So will I-40 ever end up somewhere else? I don't know. I really don't know the answer to that question. It would be a huge effort to do that. And the question is, you know, how much you would gain. But central to this whole question is how much are you willing to invest to keep something working? And really, no matter where you go in these rugged mountains of Western North Carolina and Tennessee, you're going to be challenged by the landscape. And that's something that people forget. This is a bit different of a mountain landscape than you'd find in the Rockies or in the Sierras or something like that. But it's still a rough mountain landscape, and there's still going to be a lot of challenge to dealing with it. So for the next video, I'm actually going to try to talk about the French Broad. There's a lot of hype around that river as well. Is it the better way to drive out of the mountains? Maybe, maybe not. But it has a pretty interesting story, and it has long been regarded as being pretty special, almost globally among rivers. So I'm gonna try to get into whether or not that is really a true statement. But I hope you enjoyed this video, and hope you check out that next one when it comes along.